Hey everyone, and welcome. So today we're going to dig into something we do every single day, probably without even thinking about it. We're going to talk about the conversation we're constantly having with our technology. I mean, really think about it for a second. Every time you type something into a search bar, click on a video, or even ask your smart speaker for the weather, you're starting a conversation. So how does that actually work? How does this machine understand what you want? And maybe more importantly, how does it talk back to you? You see, it really is a two-way street. It's a dialogue. You give the computer some information, and in return, it gives you a result. This whole back and forth, this entire technological conversation is built on two super simple ideas: input and output. So let's get right into it. In the world of computers, this whole process has a name. We just call it I/O. And yep, that stands for input and output. I/O is basically the bridge between our world and the computer's world. It's every single signal, every piece of data the computer gets from us, and everything it sends back. Without I/O, your laptop or your phone would just be, well, a completely useless silent box. And this simple diagram, it shows you the whole cycle perfectly. You use a device to send data in. Then the computer's brain, the CPU, does its magic and processes that data. And finally, it uses another device to send the finished information out. It's this beautiful, powerful little loop that makes everything work. All right, so let's break down that first half of the conversation. How do we actually speak to the computer? Well, this is the world of input. So an input device, its whole job is to be a translator. It takes your actions, your clicks, your taps, your voice, and turns them into a language the computer can actually understand. You can almost think of it as the computer's ears. And of course, these are the two we all know and love. The keyboard lets us type out words and commands, and the mouse is our way of pointing and clicking and interacting with everything on the screen. Honestly, they're the absolute cornerstones of computer input. But the conversation goes way, way beyond just typing and clicking. A microphone lets us talk to it. A scanner lets us show it a picture or a document. And of course, a touchscreen turns our own fingers into the input device. Each one is just a different dialect in this language of input. Okay, so we've given the computer our instructions. Now what? How does it reply? This brings us to the other side of the I/O coin, output. If input devices are the computer's ears, then output devices are its voice. They take all that processed digital information from the CPU and translate it back into a form we can actually understand, something we can see or hear or even feel. Now, these are the two most common ways the computer replies with visuals. Your monitor gives you that instant feedback right on the screen, while a printer takes that same information and turns it into a hard copy you can hold in your hands. And just like input, output comes in all sorts of flavors. Speakers and headphones give us sound. A projector can blast that information onto a huge screen. And get this, devices like Braille readers, or even the little buzz you feel from your phone, that haptic feedback, are translating digital data into the physical sensation of touch. How cool is that? So we've seen both sides of this conversation. Let's really pin down what separates them. What is the fundamental role that makes an input device completely different from an output device? This table just lays it all out, nice and clear. It really boils down to the direction the data is flowing. Input devices send information to the computer. Output devices get information from the computer. Input translates our world for the machine. Output translates the machine's world for us. We command the input devices, but the computer commands the output devices. It's all about that flow. But, here's where it gets really interesting. Some devices can actually do both. They're bilingual. Just think about the touchscreen on your phone. You use it for input when you tap on an app, but it's also the output device showing you the screen. Or a network card in your computer. It's constantly sending and receiving data. So sometimes it really just depends on your perspective. Now, let's zoom out for a second and talk about why this conversation is just so important. Because it isn't just about the technology itself. It's about making sure that everyone can be a part of the conversation. I mean, this is a really critical question. For many of us, using a mouse or keyboard is second nature. But for someone with a physical disability, those standard tools can be a major barrier. So how do we make sure they can still talk to their computer? Well, that's where adaptive I/O devices come in. And the solutions are just incredible. Instead of a normal mouse, someone might use a device that actually tracks their head movements to move the cursor. Instead of a physical keyboard, they can use one right on the screen, controlled with a simple joystick.
Or they can just use their voice, turning spoken words directly into commands.
And this right here is exactly why this all matters so much. These special I/O devices, they aren't just cool gadgets. They are genuine tools for inclusivity. They give people with disabilities the power to learn, to work, and to connect in a world that's becoming more digital every single day.
So, what's next? Where does this incredible conversation between us and our machines go from here? Because as you know, technology never stops changing.
I mean, just think about things like brain-computer interfaces, where you could control things just by thinking, or tech that's just all around us, in the walls, totally seamless. Will the line between input and output just completely vanish? Will this conversation become so natural, so intuitive, that we don't even realize we're having it anymore? That's the big question as this amazing two-way street continues to evolve.